Rationalising the Denominator of Surds with Adam Maths Tutor. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. Rationalising the denominator means getting rid of the surds from the bottom of the fraction. For the simplest type, you do this by multiplying the top and bottom of the fraction by the surd. So where we have root 6 written as the denominator, we multiply this by root 6 to eliminate the surd. But so that we're not changing the value of the original fraction, we need to multiply the top by the same amount. So root 6 over root 6. For the numerators, 6 multiplied by root 6 is 6 root 6, and root 6 multiplied by root 6 gives us 6. Since the numerator and the denominator are both divisible by 6, we can cancel, and this will leave us with our answer, which is root 6. For the next question, we'll eliminate root 2 by multiplying by root 2, and the numerator also needs to be root 2. 1 times root 2 is root 2, and root 2 times root 2 is 2. This can't be simplified any further, so we leave our answer as root 2 over 2. For the next question, we don't need to multiply by 7 root 3. We'll still be able to eliminate the surd by just multiplying by root 3, keeping the top the same and multiplying this by root 3 as well. 2 multiplied by root 3 is 2 root 3. And 7 root 3 multiplied by root 3 is 7 lots of 3. This would leave us with 2 root 3 over 21. Again, this cannot be simplified any further, so we can leave our answer like this. Lastly, we're multiplying by root 3 as the denominator, and we'll do the same for the numerator. This time, notice how there's 2 terms written as the numerator. This means we'll need to think about single bracket as there's more than one term, and we'll need to multiply both of these terms by root 3. Root 6 times root 3 is root 18, and negative 3 times root 3 is negative 3 root 3. As the denominator, we'll have root 3 multiplied by root 3, which is 3. Root 18 can be simplified to give us 3 root 2, and then we're taking away 3 lots of root 3 and dividing by 3. Since both of the terms written as the numerator are divisible by 3, we'll be able to cancel, and this will leave us with root 2 subtract root 3. On to the intermediate questions with an increase in difficulty. This time, multiplying by root 3 as the denominator will not be helpful, since we'll have to expand a single bracket, and this term will multiply to give us 3, but this will multiply to give us 2 root 3, so we'll still end up with a surd written as the denominator and therefore not manage to rationalise it. Instead, we need to use what we know about difference of two squares. So you need to keep the terms the same and have 2 and root 3, but we need to change the sign to a negative. Doing the same at the top would be 2 minus root 3 also. And starting with the numerator, we need to do 1 multiplied by 2, which is 2, and 1 multiplied by negative root 3, which is negative root 3, over, and this time we have double brackets. 2 multiplied by 2 is 4. 2 multiplied by negative root 3 is negative 2 root 3. Root 3 multiplied by 2 is 2 root 3. And root 3 multiplied by negative root 3 is negative 3. Simplifying will mean that these middle terms, when we collect like terms, will cancel, leaving us with 2 minus root 3 as the numerator. And then we'll just need to do 4 take away 3 for the denominator, which is 1. Anything over 1 stays the same, so our final answer would be 2 take away root 3. For the next question, we'll need to multiply by 1 plus root 3 for the denominator and 1 plus root 3 for the numerator. On multiplying across will leave us with double brackets for the numerator and the denominator. 2 times 1 is 2. 2 times root 3 is 2 root 3. Root 3 times 1 is plus 1 root 3. And root 3 times root 3 is 3. For the denominator, we have 1 times 1, which is 1. 1 times root 3 is 1 root 3. Negative root 3 times 1 is minus 1 root 3. And negative root 3 times root 3 is negative 3. Simplifying the numerator will leave us with 5 plus 3 root 3. And simplifying the denominator will leave us with 1 take away 3, since the middle bit will cancel. This is negative 2. This cannot be simplified any further, meaning that this is our final answer. For the last question, our fraction involves a denominator with another fraction, which also needs a denominator that has to be rationalised. The way to do this is first by rationalising the denominator of the fraction written as the denominator. So we'll have to multiply 1 over root 2 by root 2 over root 2. This will give us root 2 over 2. So now I can rewrite this fraction as 1 over, and then for the denominator it would be 1 minus root 2 over 2. So to rationalise the denominator, we'll need to multiply by 1 plus root 2 over 2, which means we'll also need to multiply it by the same for the numerator. We end up with a single bracket at the top, which is just being multiplied by 1. So this will just remain the same, 1 plus root 2 over 2. And at the bottom, we end up with double brackets. There's no need to do this middle bit like we did for the previous two questions, because every single time we do this, it just cancels to give us 0. So we can just use that same logic as a shortcut to not do it or leave it out, and just focus on doing 1 times 1, which is 1, and then negative root 2 over 2 times root 2 over 2, which is the same as negative 2 over 4, which is the same as 1/2. This will simplify to give us 1 plus root 2 over 2 as the numerator, and 1 minus 1/2 is 1/2 as the denominator. We can times the denominator and the numerator by 2 to eliminate the half that we have written as the denominator, meaning we'll have 2 plus 2 root 2 over 2 as the numerator, and this can be simplified to leave us with a final answer of 2 plus root 2. On to the advanced question, one of the hardest questions that you're likely to find on this topic. We'll need to rationalise the denominator, but notice how the denominator is written as a squared bracket. This would be the same as 1 plus root 2 over 3 minus root 2 bracket 3 minus root 2. So now we have double brackets which need to be expanded and multiplied out. For the numerator, we'll still have 1 plus root 2, but for the denominator, we can start by doing 3 multiplied by 3, which is 9. 3 multiplied by negative root 2 is negative 3 root 2. Negative root 2 multiplied by 3 is negative 3 root 2. And negative root 2 multiplied by negative root 2 would give us positive 2. Collecting like terms, I get 1 plus root 2 over 9 plus 2 is 11, and negative 3 root 2 take away 3 root 2 is negative 6 root 2. I can multiply by 11 plus 6 root 2 to rationalise the denominator, and I'll need to multiply the numerator by the same. This leaves me with double brackets that need to be multiplied for the numerator and also for the denominator. 1 times 11 is 11, and 1 times 6 root 2 is 6 root 2. Root 2 times 11 is 11 root 2, and root 2 times 6 root 2 is 6 lots of 2, which is 12. For the denominator, we have 11 times 11, which is 121. No need to multiply 11 by 6 root 2 and negative 6 root 2 by 11, as these terms will cancel when collecting like terms. So I just need to focus on doing the negative 6 root 2 multiplied by 6 root 2, which is the same as negative 36 lots of 2, and the same as negative 72. Simplifying the numerator, 11 plus 12 is 23, 6 root 2 plus 11 root 2 is 17 root 2, and this is over 121 minus 72, which is 49. Notice how the questions asked us to write it in the form of a plus b root 2, where we need to find the value of a and b. That means the answer that's written as a single fraction will need to be split up to represent each term as a fraction separately. So we have 23 over 49, and we're adding 17 over 49 lots of root 2. Therefore my value for a is 23 over 49, and my value for b is 17 over 49. Before you go, take a look at the solution which I've provided for this question. I've made some mistakes. See if you can pause the video and either tell me what they are or write down some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.